in the sense that we're ready to start. And we have a few people now in attendance. That's good enough. I think we'll start, because even if they join later, that's not a course where if you miss something, then you miss the rest. No, that will be all pretty clear. You can start from any place. And therefore, let's do this. Let us close this announcement board and remove all of the unneeded windows, which will also include the camera window. We'll just be talking. Maybe later, if we get into a discussion, maybe we'll be back to the camera. But for now, I want to show you what I want to talk about. Now, I do welcome your input as we're talking. So what I will do is I will bring up the chat. Okay, so I'll be watching the chat. If there is anything you want to ask, please do, by all means, do it right away. And I will try to answer if I can. If that works right away, I will do so. And if it doesn't, then I will leave it for a little later. But I want to have a communication. I don't want to just talk at you, but instead I want to chat with you. So please do. Now, what you see here is my internal lab, and you know that I try to be informal. I do listen to enough formal podcasts, and it's just too much. It's too much of a corporate talk. You know that I even have a little collection of corporate talk, like we're not boiling an ocean here. And there are lots of very funny. That's not what we want. We're not for that kind of fun here. So I'm showing you that place where I collect all of my slides for that course. That course, I just taught it the third time around. We do it about every 3 months, it seems. And here, what you see here are pretty much the outline of what we're covering. But I want to show you the very first one and go through that. And then we'll talk about, so what is it for you? Because we want to be useful and helpful, and we want to do good for people. So here you are. Let's look at that slide. And one of the things that I learned, by the way, as I was teaching this, is that one guy, he said, I cannot stand you scrolling up and down, and I get giddy. And I asked, what can I do? These are PDFs. He said, what you do is do the slideshow. And then even PDFs will do a slideshow for you. Well, thank you very much for that. I did not know. Let's go back to the very beginning, and I'll tell you what it is about. And then maybe together we'll work. It's more of a workshop on, so what is in it for you? Now, that course is for a company called Internet2. Internet2 is a conglomerate. It's a few hundred universities. They can be all members of this Internet2. So if we go and look at Internet2, they are real. Here, Internet2.com, most likely. Well, okay, maybe dot something. EDU, that's what it is. So as you can see, fun crowd, that's pretty much real. Now, they have a need. They have very smart administrators. And administrators means that they are technical. I mean, Linux administrators. I don't mean university administrators, who have to grab what they get. Maybe their researchers get 1,000 credits on Amazon, but maybe on Azure, or maybe on Google. So between these three, they need to be quite conversant. But, and so we wrote a course and taught it. And these guys couldn't get it anywhere else, because every other cloud provider will tout itself. And what does it call? Sound its own horn, right? Right. So they were in the end quite happy about us being outside and taking a more or less balanced approach as much as you can. Besides, we're talking about a huge battlefield between the three clouds. So I don't want to, as they say, put my head between those knives and get cut off. So I'm trying to be as neutral as I possibly can. But the need is definitely there. Most people today, even if they're not administrators, even if they're not admins in the technical sense, but they do need to know multiple clouds. It just doesn't work anymore. Now, one person who expressed it very well is my friend, whom I know from Cognizant, and now he is a head of development in Google, and he said that everybody understands in multi-cloud now. So you might say, all right, he says so because Google is somewhere between 7 to 9% of the cloud. Of course, he wants to think that everybody else needs Google and everybody else and not exclude him. But this internet too is also a sign that people do need to know multiple clouds. And somewhere in the meeting, you can puzzle a person by saying, okay, that's because you used Google Cloud, but you, or the other way around, Amazon Cloud. But the other way is, so of course you did it on Amazon and it's pretty hard. What about Google? Why didn't you think of that? That's a nice question if you want to embarrass your colleagues or your kind of competitors. So definitely there comes a need to know multiple clouds. That's what this course is about. And here you have a hard goal to reach. Now, I was lucky, these guys were extremely smart. And for example, when at the end I was teaching them Terraform, and Terraform is a way to program for any cloud, program your infrastructure in any cloud. Then if the labs didn't work, they were very happy. They said, don't fix them, keep them this way. We love solving problems. Every other class will say, your lab didn't work, I'm giving you a 2. And that is the end of the story. So yes, we're dealing with smart people, but even so, it's mind-numbing amount of information. So you'll see how I try to approach that, so that even though it is just too much information, but we can still make it useful and not fall asleep and just go crazy. So we go deep enough when we have to, but not always, and wide enough when it's justified. And the most use of this class, I believe, was really discussions. And one of the reasons for that was because we gave them lots of homework. We didn't do all of the labs right here in class. Being smart, they did the labs pretty fast, so discussions were in order. But you can imagine that you can change this approach with other clouds. So, of course, we always say nothing is really expected of you guys, because that's a good way to say it. You know, this is a popular thing. Ellie 5, explain like I'm 5. Now, where I'm going is I want to compare where we are. So how do I look at the chat in case you say something? So maybe I won't be able to react to the chat right away. Don't worry, please ask your questions. I will later on see that you ask this question. Good. So one of the things I did, I put additional informations into quizzes. And sometimes the quizzes talk about something that we never covered in the slides. So it's not properly called quizzes. It's called giving you additional information, masquerading as quizzes. But that's true. That was one way of how I could put in more information, especially on a very practical level. And so I tell people it's not to test you, it's to give you more knowledge. So when you're answering those quizzes, I'll give you a chance, by the way, guys. Since you're here, spending your time with me, I'll give you some quizzes. But it's your chance to get more information. So Google, don't think that you must answer. You're not on the test, even though it's called the quiz. So that was one of the things I did with the goal to be a cloud advisor. I think you might really appreciate this goal. All right. No, it's not a sales speech. It's a good question, but it is about the knowledge. turns out that it is phrased as a course, but how else can you talk about multiple cloud knowledge? You tell me. No, I wouldn't call it a sales pitch at all, because the course doesn't exist. I mean, it's not available. It's my question to you. How do you want to proceed with this? Is that a good answer to you, Phil? Right. Okay. All right. If not, then keep in mind, I'm presenting you with all of the cross-cloud knowledge here, and I'll give you examples. It's just that I'm setting expectations on what are we to do. What can we do for you guys to increase your cross-cloud knowledge? So we do lots of labs, and I'll be honest, we use the quick labs. Quick labs we provide to the people, and I recommend them to you as well. If you don't have an account, spend those $50 a month. It sounds like money, but the amount of knowledge you get for that is enormous, because you can run those labs non-stop. It's a one-person seat, so you get for $50, you get a chance to run 24/7. So that is the story. I'm trying to avoid a sales pitch. Okay, I promised informal. So let's go and let's look at one of the slides and how to formulate this. So this first one, we'll talk about, all right, we have multiple clouds. I am giving you an overview of the clouds. Yes, I'm giving you the differences as well, but it's just too much to present like this. And it's too hard to say, that this ocean is different from this ocean, because there are so many details. Do you like cats or dogs kind of things? They all have their own pluses and minuses. So let's give you the first, and by the way, that's recorded. So if anybody is interested, they can also, I'll give you the link, go through the slides with me, and you'll see the recording, probably on YouTube. And here are the three clouds in front of us. So first of all, let's establish a common understanding that what is a cloud in the first place. And it did work for me to show the chat, and it actually worked very well, because when I'm looking at the chat at the same time, I can see what you say, but not always, I can't promise. So cloud is, first of all, an API. That's the best way to describe what the cloud is. And comes to you on demand, scalable, you pay for what you use. That basically is the cloud, not just because it's on the web. That was an old fake definition, but because it is unlimited, like buying electricity from the cloud. So these are the companies. These percentages are basically stable. Now, the latest I saw on Microsoft was 20%. The latest I saw on Google, in one source it was 9%, the other one it was 7%, and Amazon stays about 33%. So, or maybe 36. Who are the rest? It's this, and it is also on-prem hosting. So that's the market. That shows you that you pretty much need all of them. That also shows you that they will try to compete and make themselves interoperable. So you can run Google Analytics, but you can run it against Amazon or Microsoft. That's who is who, and the biggest advantage of Amazon is they've been there first. They like to tout this. So by now they have 1,000 services and lots of different details about each service, which agrees with their goal. Their goal is to give you every imaginable use case. So whatever the use case, they have it. That's the idea. And many people go with Amazon for another reason. They have the widest possible offering. So whatever integration you need, it will be there. Then comes Microsoft, which is a latecomer in some sense. But by now, with 20%, it gained it back. And of course, the most obvious advantage of Microsoft for you is that it's Microsoft. And if you are in this world, if you develop a .NET, then that is a familiar world. They made it very user-oriented. If you compare Amazon and Microsoft, Amazon is assuming you're kind of developer. Microsoft will try to express itself even in the business user terms. Here's one example. Let's say you're running a big data Spark cluster on Amazon. So you start this cluster, you're expected to understand exactly what you do, but for the rest, it should be easy. Microsoft will give you an integration with Databricks, which is the company behind Spark, and it will give it to you in the form of a spreadsheet. So the familiar technologies of Microsoft will be the way to give it to you for your use. And then comes Google. So in some sense, Google is the leader in, for example, machine learning, definitely, right? Or you can argue, whatever I say, I'm always careful not to really say it completely and definitely, because there is always another point of view. It really depends on who you ask. So my opinions are just my opinions, and sometimes they're not even my opinions. But Google will express everything in terms of open source APIs that are familiar to you, developers. So what could happen is that Google creates Hadoop, and then that's implemented in the world. And this implementation is well known, so that's how Google will give their offering, even though the internal offering is different. But the API that will give you is the well familiar open source API. That especially goes for HBase, the NoSQL Google database. They were the originators and progenitors of this. They said big table is the way we do things after people got used to Hadoop. And this big table was then implemented in the world as HBase. So now big table comes to you as a user in the form of HBase. So these are somewhat different approaches, right? Now, for the coverage of the availability zones, they're very close. It's hard to say that there are 25 regions on AWS and 54 regions on Azure, and therefore it's twice. It's just that they divide them into more regions, more availability zones, and the three, they take different approaches. So AWS is, I would say, standard in the sense that every region is then internally connected, so that if you put things in different availability zones in the region, then these are connected with fiber optics internally. So zone to zone is fast, but zone to regional, region to region is not that fast, because that goes through the outside internet. Now, you could argue that that's not important. How many people are building across regions stuff, at least right now? Now, Google will give a totally opposite approach. They will connect every region with another region through a internal fiber optics network, so that it doesn't matter, different regions are just like the same. You can build virtual networks, VPC networks. You can build them throughout different regions, and that won't be any problem. So that's Google approach, because they like to say that Google carries 37% of all of the world's internet traffic through its own networks, and underground, undersea cables is what enables the connectivity between different regions. Now, Azure has its own approach, and it's an interesting approach. In other words, they're not exactly the same. They don't completely use the same technology, but what they do is field array processors. They are kind of adjusting their clusters when you're running them. So they're also not connecting the regions like Google. They're different regions, but that's not their strength. The strength is that they adjust the cluster settings or the cloud settings depending upon the load. So all of that, you can look it up. You can look for the lectures by Doug Berger. Doug Berger is very easy to find on YouTube, and he is the chief architect of Azure Cloud. I really like the guy. He came to Houston. I saw him. So he's a smart guy. One of the things is that if somebody is talking too official, we don't believe him. If somebody is talking too complex, we don't believe them. The real brilliant guys are all extremely simple. That is Jeff Dean for GCP. And again, I was lucky he came to Houston Rice University. I saw him here. So that also betrays my ideas that you should look for those smart people and learn from them. But it's a little bit to the side. Let's go back here. Here are the regions. That's how it will usually look, and there will be very little difference. That one I think is Amazon, but really every one of them will be pretty much the same. So we said that there are regions. Regions, they have different availability zones, and there are a few little other special things, like on Azure, the regions may also be primary and secondary. So there will be some differences in that. Now, there are some best practices that are common. And they are, you look at the region that's closest, and then in that region, there are rules, and not every application runs in every region. That's pretty much common. But later on, we'll talk about what are the differences. So it is also common to do your fault tolerance with multiple availability zones. It is also common to say, no, I shouldn't use it. I'll give you an example, CDN. CDN is for commercial applications, that content delivery network. And that's propagated or promulgated or advertised as the best practice. Yes, it is, but it's expensive. So if you're making money on streaming your audios, then yes. If you are a researcher, and that is close to my heart because that course initially is for researchers, then S3 and other blob storages work just as well, and maybe better. Now, there is also the thing that you will see throughout the clouds. Now that explains pizza as a service. I'll skip that, that's just a funny thing, but this is offerings as a service. So we all know that there are 4 levels. There is a level where you run your everything by yourself, and that's on-prem. But then there's also infrastructure as a service, where you get all of those things taken care of, and you're on that level. Then there is platform as a service, you only deal with this. And then finally, you get software as a service, some kind of accounting software, for example, you just use it. So that will reflect into when you take your application and move it into the cloud. It will reflect on what are the best practices. The best practices are right here. So the best known terms are fork, lift and shift, or forklift, where you simply take your application and host it in a different place. And that different place in this case is Amazon, but it can be any of the clouds. So that's a common approach. Now, Amazon, they have, it's easy to find that the blog post where they explain those 6 R's, but I beg you to only pay attention to this rehosting, which is lift and shift. You take your application and simply copy and move it to Amazon, which will be the quickest way. You can do it in days. And so if you're in a bind and you're losing your contract, that's what you do. But the other one is refactoring right here, number 4. That's where you change the architecture. For example, in rehosting, you might already take your database and use a database as a service. But if you do any more of that operation, if you do the backups, automatic backups that the cloud will give you, if you do multiple availability zones, that's already coming to refactoring. You're changing your architecture. Better yet, let's say you have your standard SQL implementation of something, And you see that some of it should really be NoSQL. So you implemented in a NoSQL database, you re-architected this. Or another thing, you have hard-coded connections between parts of your system, and you really want to go into the modern world where you will have microservices and components. So one of the best practices here is to use a queue. Let's say you have incoming orders if you're talking about business, or you have picture processing if we're talking about entertainment, or anything else where you get a few things to do. So what you do then, you put them on the queue. And that queue, many machines then can read from that queue. So you see that, first of all, there are no more hard-coded connections. And secondly, you can scale up and down. Now, the other four R's, I think, are just to have 6 R's. You didn't have to retire as an R get rid of, but it's a well-explained things. That's what I would look for when I'm talking about clouds in general. Any cloud will more or less have the same choices. Okay, that's the same picture for those. Now, guys, all right, I promised you an example of knowledge check. So do you want to try this? You can put your answer in the chat. So you're saying D. First comes AWS, and then comes Azure, and then GCP. I agree, right? That's what it is by market size. Do we have any more? Yes. You know what? I'll give that to you as an exercise, but I suspect there was not an exact. It should be from the most amount of work to the least. Let's do it this way. So you're saying infrastructure as a service. That's from the least, right? PSS. The problem is on premise where you do all the work, so it shouldn't be there. It's probably more like A, right? Probably. On-prem, you do a lot of work, if you trust my correction. And then infrastructure as a service, platform as a service, and then finally, software as a service. Yeah, now we all agree it's A. We're doing very good, right? I think just one more. So I think that you are answering A or maybe D, right? D. It seems like you're all answering D. Yeah, I would agree. D, rehost, that means lift and shift. All right. So, okay. Now let's look at some specific clouds and what we can say about them. Last reminder, it's a dangerous exercise in the sense that every cloud is extremely big, not in terms of the size of the data centers, but in terms of the offerings and the approaches that take. So if I try to summarize it, I'm always running the risk of being very superficial, but at least let us try. So here's Amazon, 1,000 services. Supposedly you can do absolutely any use case that there is there. One interesting thing there is, okay, these are all of the services, but they will also have Cloud9. That is an IDE that runs inside of the browser, supports 40 languages or so. You don't have to install anything, and that's one way to run. It does run on a micro instance. So you do pay when you run it, but this micro instance gets stopped automatically after a couple hours that you're not using it. So that's a nice thing that you have there in the cloud. Another nice thing is that today you get in every cloud. It used to be just that one cloud, but now everyone. And the best way to do is I'll just show you real quick. So let's go to Amazon maybe. I did Amazon just because it's the fastest way to me to get in, 1 click as opposed to Google 2 clicks. And look at that. That is called Cloud Shell. Pretty much called the same thing in every cloud. So what it starts for you is a virtual machine. Again, it's a micro virtual instance, but you don't pay for that. That one is free for you. And when you run that, it is run and configured with the Amazon credentials. So for example, let us say you want to do Terraform. Well, I find that the best way to do Terraform in this environment because one second, because it always works and it is free. And also because it stays there. For example, you see that it's taking maybe a minute to start, but then it will also copy everything that I have done in the previous invocation. So I will see exactly all of my files, all of my installs. Terraform, by the way, is not installed by default here. By default, it's not, but since the last time I was there, I did install it. Well, here it is. All right, so that's talking about Cloud9 and a similar offering you have on many different clouds that you have another way to get to the shell. Every cloud today has it. So that's an AWS toolkit, but here's the shell. I already showed you that tool and I'll show you why it's such a nice thing. Now, let's look at Azure for comparison, okay? Also, lots of services, integrated services, and presented in the way of Microsoft. So if you're a Microsoft shop, of course, you don't go wrong with the Azure cloud. But beyond that, Microsoft is luring you into this by saying that every new thing will come to Azure first, and then other things later. And it will be integrated with other Microsoft things. For example, let's say you subscribe to Office 365. Well, it's kind of the same thing now, even though Azure is for developers and Office 365 is for business users, but you can use the same setup. You can use the same account. Google, by the way, does the same thing. You manage your users in Google, which you run as a service. You know, everybody has a Google account and then maybe an organization. That's where the users come from, and then they transfer into Google Cloud. Amazon is not exactly the same because there is no kind of environment on Amazon in that sense. Microsoft Azure has 365. Google, it has a Google account. Well, Amazon doesn't run that. Well, so you see some of the differences, and these services that you get are pretty much the same services, like virtual machines, like VPC networks. But beyond that, everybody needs to brand. So you need tables. I hope I'll show you some tables today where you will see how each thing is called a different name in the cloud. And that's only the first 3 clouds. When we come to more clouds, I'm sure we will come to more clouds, then your life will be a bit harder even. So everything that Microsoft builds, they build first for Azure. Well, that brought the company valuation up 3 times. So it definitely works. They were 300, I'm lost in these numbers. I don't have that much money, but 300 billion, right? And now they are at a trillion and more. And so that works. I'm sure they will continue with this, but the professed goal is that every feature goes to Azure first. All right, so that's the good reason to be in Azure, right? So now the same idea, regions, data centers, plus there's something else special about Microsoft. They have a special Azure for Department of Defense, a special for the government, a special for China, and then a special for Germany. Right, that's what is special about them. But that one, every cloud internally goes on a 22 millisecond network trip. That is part of what they do with the programmable, you remember those programmable IPFG, programmable field arrays. That's the Azure You see basically the same world coverage. And now let's talk about GCP. Okay. So here is the Google way of looking at things. It is somewhat different from all of the previous ones because Google likes to show, well, we've been there first. We kind of been there before you, even though maybe business-wise it's not like that. By the way, Google said that they predict that they will be player number 2 in 5 years. They said it about a couple of years ago. We don't see that happening, but there is enough money for everybody. You don't have to be player number 2. You can just as well be whatever player. That's not important. It's important what you do. And oops, don't run. Don't run. These are the major steps, and where they're leading is machine learning here, and all kinds of looking for the Docker and Kubernetes. So much of that is Kubernetes. One special thing here is Cloud Spanner. So we are used to hear that databases don't scale, and that's why you have all of the NoSQL databases. So if you want a real large NoSQL database, SQL database, it doesn't exist. And instead you hear about NoSQL principles and eventual consistency. So real consistency, real SQL is not possible at scale. Well, no, not true. Cloud Spanner is a SQL that is worldwide consistent. It does cost, but if you want to collect money from the whole world, then probably it's a good thing to have such a database. So that's what they show as special offerings. Now, my personal opinion is that probably these special offerings are great for them, but how many other companies are having business the world over and need to account for all of that? Maybe not everybody. The same probably goes for machine learning. Super important, and you can have parts of your systems implemented there, but probably not overall completely so important that they are getting their market share based on that. Well, we're not upset about them. They still get their market share. So here is the regions. And as we mentioned, the special thing about Google regions is that they're all connected. Now let's try to do cross-cloud comparison as much as we can. These are the mind-numbing tables that I promised. And let's look at one of those tables. So let us say let's go to the bottom, serverless functions. Serverless functions means that I don't care what is the server that I'm running on. I just want you, the cloud, to run my Python script or any other 7 languages. So I give it and it runs, and it has limitations like 5 minutes, no more to run. But it runs basically in every cloud. I'm giving it my script, and it's a great way to save money, because if you're setting up the normal thinking is I'll bring up a server, it will be doing my work. And then I'm paying for every second that that server is running. Now, every second that's for Google and Microsoft. Amazon usually does per hour. But that depends upon the situation. Right now, Amazon has situations where it's doing by the seconds, so that it's not a definite advantage of any other cloud. And then how much are you saving really? So that interval where they charge, that doesn't matter all that much. Now, the serverless functions will run, and they will run within milliseconds. And you can integrate the rest of the cloud with it. You can use, let's say, the Google machine learning, or you can use Azure functionality that is specific to Microsoft or Lambda, but it's called a different name. Look, AWS Lambda and Azure Functions and Google Cloud Functions, not the same. So what's important is the left part. You need to know that there is such a thing as serverless computing as an whole idea. You don't run your server anymore, and you don't pay for it. You only pay for the time it's running. The next one is containers. If you package your application as Docker and Kubernetes, then you fit into everybody's model, especially Google. They really love you packaging everything this way, but they will call it different. Google Kubernetes Engine. Now, they have been rebranded. For example, if you know Google, they have the stack driver. That's the debugging and administration. It's not stack driver anymore. It is Google administration. And that goes for everything. It starts with the word Google. Okay, so that makes it not very comprehensible because now you need to start with the word Google, and they all like GCE, that's Google Compute Engine. That really is virtual machines. So if they all called it virtual machines, I would be happier. But on Amazon, that's called Elastic Compute Cloud, which you of course remember that was the very first how they called it. And on Azure virtual machines. Then there is this PaaS, which is a platform as a cloud, which means that, let's say I want a web server. Well, so I write a web server. Maybe I write it in Java. And then I package the code into a jar. Or maybe I write it in Python. And then I package the code into a zip. And then I give it to the cloud. But on Amazon, the place that I give it to is called Elastic Beanstalk, a historical name. And on Google, that was the very, very first offering. It's called Google App Engine. And you go figure that these are the same. And finally, App Service and Cloud Services, that's what it is called in Azure. So Azure will regroup some of those things. For example, all of their databases will be kind of under the same. Some of them SQL, some of them NoSQL. Good, that's for the compute services. Now the storage. Let's go through every one of them. That's a very good indicative of how they do it. Object storage, blobs, big binary objects. So on Amazon, it's called S3, Simple Storage Service. On Azure, it's called Blob Storage, which I think is the best name. And on Google, it's called Google Cloud Storage. You need to remember that Google Cloud Storage refers to blob storage and not any other storage. GCS then, and that's how you will be abbreviating it. Then block storage, that really is hard drives. So when you're asking for a hard drive, it's called EBS, Elastic Block Store. It's likely called the block store on Azure, but on Google, it's called persistent disks. Also, Google persistent disks are special in the sense that they come in fixed sizes. Others, you just choose your size. Here, it is in-memory fast drives, and they are all 365 gigabytes. You can have up to 8 of them, so that makes, I think, 2 terabytes, right? Oh no, 3 terabytes. So that's somewhat special. You'll see this on the test if you ever take a test. Then there is the next idea, cold storage. They all will have cold storage where you will pay less. The best discount you can get is with Glacier, which is 4 times cheaper than online storage. And what you give up here is how fast you can get this data. There is a bit of a difference in the implementation. You need to move from one storage to another on Amazon. You don't have to do anything special on GCP, but the basic ideas are the same. You have a way to save money on every one of storage, and keep in mind, there will be devices and limitations on what exactly you do. And then comes the file storage. The file storage is somewhat new as an offering in the cloud, but somewhat old as the technology. It's just our regular file system. But you can have it any size, and it will work for especially old application, kind of shared drives, shared mountain storage. That's what it is. So on Amazon, it's called Elastic File System, and Azure is Azure File Storage and Google File Store. Cool, that's the storage, but there are also networks. So here you can relax a little bit because VPC for our private networks, they're also VPC for Google. Wonderful. And close on Azure. There are also load balancers, which are obvious things. Everybody's using load balancer. And then the word is balancing. That's good. Peering. Here, what you need to know are the general ideas. You can have different VPCs and they can talk to each other. That's what is called peering. Finally, every one of the cloud will give you DNS under somewhat different name. Google calls it Route 53. The others will call it DNS. Cool. Now the data stores is where there will be some variety. That's because some of them, like Google, likes to call everything a data store. So any kind of storage, blob storage, let's say any kind of database and any kind of file system, that's still data store. And some, they separate the data stores as really databases. So with that, we see that there will be a NoSQL of different sorts, quite a few different sorts. And there will be an SQL and RDBMS run your database. Now, everywhere you should exercise some caution because the best practices are for the paying customers. For example, I have a case where we should be using Amazon RDBS as a service, but for that particular client, it's still so much more expensive than running your own server and running a database there that we're doing a bad practice and we're not using database as a service because, well, the databases are quite developed. They will do your automatic backups. And how often do you need to upgrade? So clouds are nice. They are selling you the best practices, provided that you're willing to pay for the best possible ways. Beyond that, yes, these are the best practices. You have SQL, NoSQL, and all of them as a service. Cosmos on Azure is somewhat different because it combines regular databases and NoSQL databases. So if you could possibly summarize that in one word, then you could say that AWS is mature. Well, everybody else is mature, right? They reach the age of maturity. But that means that you have probably the largest amount of different services that they all come together. So you will not go wrong on choosing any one of them. But on some specific areas, it's good to compare between the three and see things like, okay, let us say you are building your architecture, and usually every exercise on building the right architecture is doing this. It says, here's the cheapest way, therefore that's what you should do. Well, but look at the timeline. Yes, it is the cheapest way now. But is that the cheapest way in the year from now? It could be that it changes a lot. The clouds don't change their prices all that much. They're pretty stable. They used to go down a little bit every year. I don't see that anymore. But very often your solution is not really even buying it from the cloud. I'll give you a couple examples. So it used to be that on Amazon, your multiple departments could get a combined account and get the discounts. That's not the best practice any longer because it's not convenient for your departments. It's very hard for them to get the broken down invoice, right? So there are third-party companies that give you those services and nicely broken down invoices. That changes almost every year. That announcement came last year on Amazon. And that's not the best practice anymore because of the proliferation of third-party providers who do it for you, and they will give you those discounts. But they can change the pricing. So let us say you put a lot of data in S3 and they suddenly change the pricing on S3. The cloud won't change it abruptly and they won't change it 2 times. Those providers will. So when you're building something on the cloud, don't just look at what it is today. Look at what was the history. Look at what maybe even projections. Now that's Amazon, right? So they have a huge service portfolio and they're everywhere. Now, Azure, they are great for developers, those developers who are Microsoft developers. Yes, totally agree. And that would be a very natural choice. So the integration with the open source, Microsoft is different from what it was, and they do a lot of open source initiatives, but nobody completely trusts corporations anyway. Example, well, you can get better security with Microsoft, but at the cost of the log price. So Microsoft does this, they charge you for every additional log level, and even those that are a must for security. And they don't always announce breaches. Look at the latest what's going on with Microsoft, how they had a huge breach, which they did in small letters at the end of their regular updates. So integration with open source is good. You can talk about bad stories about Amazon, bad stories being that they like to kill open source by putting it into their offering for free, and the whole story. I'll be happy to talk about this, but it's not always exactly the same. All right, so we say integration with open source, yes. Attractive pricing model, one on Google, one of the attractive pricing models here is the sustained use discount, which there was a rumor that is going away, but no, I don't think it's going away. So attractive growth and attractive discounts means that if you run it for a month and it turns out you ran it for a month, you didn't have to tell them up front. After you run it for a month, then you will get the discount. That's nice. On the other clouds, you would have to first tell them you'll run it for a month and then get the discount. Now, the aggressive growth of Google, it's in the sense that they're investing a lot. So if you're trying to be a partner with them, it will probably work somehow if you're big enough. But aggressive growth in numbers, again, we don't quite see it. The aggressive attempts to grow, right? And definitely they will be the one of the first AI. If you can build your prototype for AI just on that, then you could probably get the best possible quality. So these are my opinions, as I mentioned, and I wonder, no more special questions. So any questions that you want to ask now, that's when we can stop sharing, even do the camera, and I'll be waiting for your questions. So my question to you, was it too much? I mean, did it feel like too much information, too many clouds? It seems like no. Some people say it was even helpful. All right, and then my question is, do you think it's interesting for other people? Right now, Internet 2 is the only organization that uses it for clear reasons that I explained. Should I try to think of making that a course? The course is the whole thing, right? It's a lot of things that you discuss. And for every such topic, like how do you save money? Each cloud is different. And so how do you do it in each cloud? What are the common principles? Like, let me ask you that question. How many people have to work on multiple clouds almost at the same time? Like this. Do you have to work with multiple clouds? Yes, you do. How many? 2 or 3? 3, all right. And that could also include others like IBM. All right, that's awesome, guys. So thank you very much. I really enjoyed that. And I really enjoyed your reaction for including IBM. That's right. And so if you need anything, then you can always ask this question. You have all the emails, you have all of the contact information. You will get an email saying, here's the recording. So if you want to listen to it again, yes, you will get the recorded version that will come in an email a day or two. after? Okay, what is Internet 2? Good question. So here we are. We have 1 minute to talk about this. That is an umbrella organization for multiple universities. A few hundred universities belong to it, and it's helping its universities to deal with clouds. I'll give you an example. They have, every cloud will take your data. So the ingress, putting the data in, is free, but it will then ask you to pay for getting it out. So if you're a university, you can ask for, through the internet too, you can ask for a discount or for a zero charge on getting the data out. So that's what they are for. They are combining the bargaining power of universities. But they're also doing other things that if you are a cross-cloud thingy, then they're publishing this course, or at least they're making it available to the universities. Okay, was that your question? Okay. Okay, let's give it a minute. Maybe you will ask some more questions. Thank you. Thank you. All right, very good. You will be able to ask some more questions if you want later on. For now, we'll have to say goodbye, all right? And I wish you a very good weekend.